Hey everyone, welcome back. This is video number 3 in our organic overview. In the previous video we learned how to name alkenes, alkynes, and most importantly alkanes. And those molecules were all hydrocarbons. They were all carbon-hydrogen atoms only. We did see an exception where there was a chloro group. But by and large, if you just have carbon and hydrogens, they're just called, just named alkanes, alkenes, and alkynes, or aromatic. In this video, I want to talk about functional groups. And what a functional group really does is introduce some of the variations we can have in organic molecules when we start placing oxygens, nitrogens, some sulfurs from here and there, maybe a phosphorus here and there, but primarily oxygen and nitrogen into our chains. The oxygen and nitrogen can be either groups that replace one of the hydrogens in the hydrocarbon, or they can insert themselves in the chain of carbons. And so like instead of just having C, 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 we can have COC, or maybe even CNC in the chain. Each of these functional groups has the potential. They really do have their own naming systems for each. It's a bit cumbersome to learn it all. So we're not going to, but when I say we're not going to really go into all the details, I don't want you to think that what we're doing is not important, because it is. These functional groups really open us up to the possibilities of organic chemistry. These are how you make your fats, your proteins, by putting in these functional groups. So they are extraordinarily important in terms of outcome. In this picture here, I've given you some functional groups. And as we go through it, well, let's start at the top. So alkane has no functional group. Alkenes, you can count the double bond as a functional group, and alkynes, you can count the triple bond as a functional group. We're not really going to do that. I don't want to overcomplicate things. So when I say functional group, I want you to think of oxygen inserts and think of nitrogen inserts. Now let's go to the bottom and let's talk about the simplest functional group, and that's when we replace a hydrogen with an OH, or a hydroxyl group. Those are called alcohols. Now let's talk a little bit more about what these R groups mean. I know it can be confusing when you first look at it. An R group is any amount of carbon chain. So it could be as simple as a methyl group, which is just a CH3 here. It could be 20 carbons in a row. It could be some carbons, an aromatic ring, and then some more carbons. So it could be anything. That's just the carbon-hydrogen chain that's out there. We do this to simplify the writing. Instead of having 20 carbons out to the left of this OH group, I can just write R. And then I can just focus in on the fact that it's an alcohol. So we use R really to abbreviate the structure, make it easier to draw. If I have an alcohol and R is a methyl group with just one carbon, then we would call it methyl alcohol, or just methanol, where now your suffix changes from ANE or ENE to OL for alcohol. So every type of compound we have in organic chemistry sort of has its own suffixes. Alkanes are ANE, alkenes are ENE, alcohols end in OL. If the R group here was 2 carbons, a C2H5 substituted group, or main group I should say, really, that's an ethyl, and so we'd have ethyl alcohol or ethanol, which I know you've heard of. And we could play this game up to dodecanol if we wanted to. So those are alcohols. Alcohols can be further classified into primary, secondary, tertiary alcohols. And when we have those, we have to really look at the carbon, this carbon that it's connected to, because if that carbon has only one OH and then the rest of them are hydrogens, or at least 2 hydrogens, that's primary. Let me back up and make that clear. So a primary alcohol is just when the OH group is on the very end. So the carbon here would only be connected to one other carbon. Okay, I think that also includes methanol, which has no other carbons. So if the R group is just carbon and then hydrogen on top, hydrogen on bottom, and then one more carbon, it's primary. And then if you put the OH on other places in the molecule. We saw in the alkane naming that it can go anywhere on the chain. If the carbon that it's connected to is connected to only 2 other carbons, then we call that a secondary alcohol. And if that carbon is connected to all 3 other carbons, then it's a tertiary alcohol. And the only thing that really changes here are the physical properties. Let's don't get too bogged down in that. Another very simple substituted group is, instead of putting the oxygen on the end like in an alcohol, let's put it right in the middle of the chain. So this R group here on the left and the R group on the right, it could be any amount of carbons, but here we have the carbon-oxygen carbon bond here. We call those ethers. Ethers look symmetric, and they ask this on the AP test quite a bit, actually, because if you remember from pre-AP, the oxygen has to have the octet, so there are always two lone pairs on the oxygens and ethers, so they actually have bent geometry, and they are slightly polar, depending on the R groups. But you can, typically when we name ethers, we just say, like what this R group is, it could be a methyl, and then this one could be an ethyl, so we'd have ethyl methyl ether. If they're both methyls, we could have dimethyl ether. Well, those are just some simple ones. How about instead of oxygen, we do an SH group? Oxygen and sulfur are in the same column, so we can very easily make this happen. Instead of alcohol, though, we call it the thiol. We did that a little bit in pre-AP when we had sulfate, SO4-2, and when I replaced one of the oxygens with a sulfur, it became thiosulfate. So anytime you see that thio in chemistry, that means you replaced an oxygen with a sulfur. So very similar chemistry here between the alcohols and thiols. And we can do the same thing with the ethers. We're not going to focus too much on thiols and thioethers. Let's jump up now to a couple rows above. We'll talk about the amines. Amines are nitrogen inserts. So we can have the primary, the secondary, and the tertiary amines. That follows the same pattern I talked to you about with the alcohols, primary, secondary, tertiary alcohols. Don't get too hung up on that. Here's the important thing about amines. The amine is an NH2 substituted group. Okay? Have you ever heard of amines? Absolutely you have. Amino acids are amine compounds in your body. So these are very important. So just amine is a single bond NH2 group. Now, let's go up to the second row now, and let's talk about a very important group in functional group chemistry. Here, we have a C double bond O. And make sure you understand, I'm pointing at right here as a vertices, is where 3 lines are coming together. Even though it's not shown, anytime in organic chemistry, when you see vertices, that's where a carbon is. Let's go up to the alkene. See this little spot right here? That vertice, that's a carbon. Here's a carbon. At the end's a carbon. So anywhere you see the end point of a line or a vertice, that's a carbon. So in these functional groups, you have carbon double bond O. That is a very important group. We'll see that again later when we do acids and bases. That is called a carbonyl group. Carbonyl, C-A-R-B-O-N-Y-L. There's a lot of important chemistry that comes along with this group. So when we have the carbonyl group, that becomes sort of the center, the focus for that particular molecule. And so what happens on either side of the carbonyl groups gives us a lot of potentials for types of molecules. So in our first one, we have a ketone. A ketone is when you have an R group on either side of the carbonyl. Remember, R groups are just carbon-hydrogen chains of various lengths. Okay, so you've heard of some ketones. You've heard of acetone. That's the most common one you've probably heard of. The ketones are very important in a lot of medicines you take. If you look at the backs, the ingredients of a lot of medicines, you're going to see some ketones probably. Another group around the carbonyl is if I have an R on one side and an H on one side. So this is important because when I have the H here, that terminates the chain. So this will always be at the end of a molecule, whereas a ketone could be anywhere in the chain. You can sort of insert it anywhere, but aldehydes are always at the end. So that COH group here, the functional group, is what distinguishes an aldehyde. You've heard of formaldehyde. Formaldehyde is the simplest aldehyde, and that's when the R group is also an H. Formaldehyde is really a very simple compound. It's CH2O, and the R group is just an H as well. You can have F-aldehyde. Ever heard of F-aldehyde? That's going to be C2H4. Nope, that's not right. Let me count that up real quick. Let me do my math. I think I had it right. C2H4O. I think that's F-aldehyde. All right, another very important group is the carboxylic acid. So again, we have the carbonyl, and now the substitution on one end is the hydroxyl group. Again, that will terminate the chain, and then on the other side you have another R group of indeterminate length. So when you have this, we call it a COOH functional group. Those are called carboxylic acids. You've heard of methanoic, well, the simplest one is called formic acid. I'm sure you've all heard formic acid. That's when the R is just a hydrogen. You've heard of methanoic acid maybe. Have you ever heard of ethanoic acid? I bet you have. That's going to be your acetic acid. That's a synonym for acetic acid. The acetate ion that we learned in pre-AP is actually a carboxylic acid polyatomic ion. Let's get a little bit more complicated. Let's take that CO carbonyl. We'll have the R still there, but in this time, instead of OH, where it terminates the chain, let's do OR. So we can take the ether, if you go to the bottom, remember our ether, and we can put it on one side of the carbonyl group. That becomes an ester. And yes, students confuse ethers and esters all the time. You've heard of esters. You've heard of polyester. Esterification is a way that we make fuels. So this process is very important in chemistry. Okay, so that's the COOR around the carbonyl group. All right, I'm going to skip the acid halide. Don't worry about that. The only other one I want you to focus on this page is the amide that I'm circling with the cursor here. So let's take the same carbonyl. We have the R group on the one side just sitting there. In this time, let's put the amine group. Now, if I put that NH2 to distinguish it from the amine, letting us know that it's part of a carbonyl, CONH2 now, we're going to call it an amide. So again, we have another potential for confusion here. Ethers and esters sound alike. Amines and amides sound alike. You have to memorize which one has the carbonyl. For the oxygen, the ester. Ester is a combination of the carbonyl plus an ether. Amide is the carbonyl plus an amine. I'm sorry, I don't really have a good way to help you remember that. It's just memorization. So the naming now will get really complicated. We're not going to do a lot of naming with the functional groups. Really what I want you to do with functional groups is be able to recognize them. As we talk about the biological molecules, we'll point out some of these functional groups. As we read about some organic molecules and throughout the semester and the year, we'll point out the functional groups and kind of acknowledge that, hey, that's where the chemistry is going to take place. And it'll also allow us to take molecules that look kind of random, and we can start classifying them into common groups based on what we see here. Carbonyls with 2 R groups, so that's ketones, and that really starts bringing order to some chaos, in my opinion. All right, we're going to do some practice in class where I give you some molecules and allow you to start classifying. I will say, just in closing here, that we talked about the alcohols ending in OL, like ethanol, methanol, propanol. Ethers do have a bit of a weird thing. But ketones typically end in ONE. Aldehydes typically end in AL, believe it or not. So like ethanol, methanol, propanol, those types of aldehydes. Carboxylic acids are pretty easy to recognize because they end in the ic acid, ethanoic acid, benzoic acid. Those are pretty easy. And then we don't really have much crazy stuff for esters. But I thought I'd just point that out. If you see ONEs or ALs, that'll help you out. All right, you're going to have questions on this, so if you do, make sure you ask. Otherwise, we'll do some practice together.